Okay, evaluate the following integrals, and the first integral we have is integral of 8x to the power 3 plus 3 divided by square root of x plus 5 dx. Now to evaluate this integral, like it's I think it's the simplest one. So be 8x to the power 3 because there is no rule that applies. All we do is just the antiderivative. Now x to the power x, the square root of x is the same as x to the power half. Now I don't want x to be in the denominator, I'll take it on top. So the power becomes negative half. Okay? And then plus a 5 dx. Now I can find the integral. This is going to be equal to 8x, add the 1 to the power, that becomes power 4. The same 4 divide by it. And then you have got plus 3x. You have got a negative half. Add the 1, that becomes positive half. And then the same positive half, bring it down. And then plus a 5. Since it's a constant, just add an x. Always add a constant. Okay, always add a constant if it is doesn't have limits. And this gives us 2x to the power 4. Now 3 divided by half, what do you think? What will be the answer? 3 divided by half.
6.
Yes, so this is going to be a 6. But remember, we've got x to the power half, which is simply square root of x, then plus 5x plus c. So this is it. We are good with this one?
Yes.
Alright, so the next one now, still evaluating the integrals. This one is saying evaluate the integral x over square root of x squared plus 9 dx. Now when you see a question like this, okay, you now start thinking of the rules of integration. So for this one, when the powers differ by 1, like you can see here, I've got a power 2, here I've got a power 1. If the powers differ by 1, you can use u substitution. But not always. Like if you had a plus 1 here, you wouldn't have used u substitution, you would have used change of variables. Okay? So in other words, you should have more like only one letter, and then the other one which is bigger, like it is one power higher than the other one. So in this case, we're going to say let u be equal to the one in the denominator, x squared plus 9. And then we're going to differentiate u. This will be du, that is going to be, what is the derivative of x squared plus 9?
2x.
Yes, 2x. Now remember always to add the dx. Okay, don't forget to add
Yes.
dx. Now let's make dx update the formula. So dx is going to be equal to du over 2x, like I've just divided both sides by 2x. So that means this integral is going to become the integral of x over square root, where there was x squared plus 9, we are going to put u. Where there was dx, we are going to put du over 2x. So this x and this x can cancel out. So this gives us the integral. Now we know that x, I mean square root of u is the same as u to the power half. Now I want to take that one on top, so it becomes u to the power negative half. And then we are going to have du. So from here, just like we did on the previous one, to integrate this, add the 1 to the power. That becomes u to the power positive half. The same half divide by it. Okay? And then just add the constant of integration u. So what is 1 over half? 1 divided by half is what? Pardon?
Is that 1 over half or half over half?
1 divided by half.
Half.
say 2. 1 divided by half. So this is going to be 2u to the power 1 over 2. Now we know that 1 over 2 is the same as just square root of u plus c. Then we get to substitute back. What is u? U was x squared plus 9. Then plus c. So this is it. Is it okay?
Yes, it's okay.
Okay, let's look at another one. This one is saying evaluate the integral of x e to the power 2x dx. Now for a question like this one, I think the easiest you can use is the tabular method. You can use by parts. Now it seems like it gives people problems to use by parts. So the tabular method is very easy. All I'm going to do is I'm going to put the sign. Can you switch off the mic? Sign, derivative, integral. Now you are going to look at this. You want to put something under derivative, that something that you can, if you differentiate it, you get a 0. So obviously that is going to be x. That's the one you're going to put under derivative. That means this other one which remains, we're going to put it under the integral e to the power 2x. Okay, and then the signs are alternating. So firstly, what's the derivative of x? What's the derivative of x? No response. So when you differentiate x, you are going to get a.
Sorry, I was talking to dad. That's why I couldn't
If you differentiate x, you are going to get a 1. If you differentiate 1, you are going to get 0. So we want to reach at 0. Then you go to the integrals. Now if you are integrating exponential functions e to the power 2x, just differentiate the power. If you differentiate the power, you're going to get 2. So divide by 2. So that will be e to the power 2x over 2. That's the same value that you get. Again, integrate this one. To integrate it, just differentiate the power. That will still give you 2. So this will be e to the power 2x. That same 2 that you've gotten, divide by it, but you already have another 2 down, so it will be 2 times 2, which will be 4. So the signs alternate. You start with the positive, negative, and then positive. Now these we are going to be multiplying them in a diagonal like this. Okay, so that means the integral of x e to the power 2x dx is going to be equal to, get this positive times x times this, that is going to be x e to the power 2x over 2. Then you get this negative times 1 times this, that is going to be negative e to the power 2x over 4. Just add the constant of integration c. That is it. As long as there is a 0 here, that is all you do. But if there was no 0, you are supposed to also multiply in this way. But that would be something else, right? So this is it, and this is the integral.